All right, welcome. Today, Peter and I are here to tell you the story about Tailored for Spark, kind of eBay's journey from where we started with Spark and certainly where we're going. Again, my name is John Scheibmeyer, and let me tell you quickly how you can basically tailor Spark, your Spark experience in your environment for maximum impact. And it's pretty simple. There's two pieces. The first piece is really the infrastructure, the hardware part, optimizing the manner in which you use your hardware for Spark. Second, you optimize the user experience, basically. So the combination of the how you leverage your infrastructure for Spark, and secondly, how you tailor or customize that user experience. Those are the kinds of things at eBay that we're really driving to tailor that Spark experience. So we're going to do this. There's two of us. There's actually four of us from eBay made the journey from California over here. We're having a great time. I'm going to do the first half, kind of walk you through eBay analytics, Hadoop, and then kind of the Spark, where we started and kind of where we were prior to starting the Spades project. So the Spades project is kind of our internal project, and it covers basically how we're really taking Spark from what people were accustomed to really that next inspirational kind of, or certainly where we want to go with it. So I'm going to do the background. Peter's going to come in and kind of show you what that solution really looks like. And if you hear me say Spades, again, Spades is basically the internal project that we use to describe this effort. And then we'll do questions at the end. So first, there's a couple, I always do this, so forgive me, but there's a couple things about eBay that I always like to kind of air out. And so first of all, there's this, when you think of eBay, usually you're thinking of, this is where I go to find weird stuff I can't find anywhere else, and maybe it's used or something like that. Well, the reality is more than 80% of the items that are on eBay are actually new items. And the other two things that I'll call out that are pretty interesting to me, that I'm glad to see, is 57% of the business is international. I think that's great. And then also interesting is 40% basically of our business comes from mobile. So when I'm giving this presentation, I get this slide and I look out in the audience and I see people on their phones. I'm thinking, that's awesome, people are shopping on eBay on their phones. But that's, anyway, a couple little insight of basically where kind of eBay business is transforming, and certainly some of the vectors of growth. Analytics at eBay. Again, this is a slide I've been doing for a while. It's changing over time, but I say, I think we're really at a crux where it's about to change a lot more. Analytics, we kind of talk about three ways to do it. There's ingesting data, there's consuming data, and kind of storing data. On the consuming data, we leverage multiple BI solutions. We use Kylin. We were a big influence in the beginnings of Kylin, MicroStrategy, Tableau, SAS and R. All those kind of things are certainly key in our BI side. And the ETL side, it's pretty fluid, but a lot of the plumbing underneath many of the data flows it's leveraging ab initio functionality. And on the data platform side, still large footprints of both Hadoop and Teradata. And two things that basically are really going to make me rethink how we do these slides is where streaming's coming in. So streaming and Spark. Streaming this year, a huge kind of organizational effort in building out a centralized streaming platform, Rios. And then on the Spark side, again, with our Spades project, another big project, another big initiative, basically how we're doing that. So both of those things are going to have some kind of fundamental change in basically what analytics stack looks like next time we do this presentation. Now, I want to talk a little bit about Hadoop at eBay. So I think there's a couple interesting stories here. Maybe the size isn't that interesting, but I think what is interesting is the spectrum of kind of use cases. We have kind of online basically to offline. And kind of starting from the online side is if you look at eBay in the typical user experience, it's not usually a browse experience. It's much a search experience, meaning typically when someone comes into eBay, they know what they're looking for, and the way they find that is through search. So if I was coming in and I'd come to eBay because I was looking for jeans, Levi's 501, 3432, that's my search bar, right? So search is really integral to the business and the way our site operates. And in fact, a large portion of that site functionality or technology is Hadoop-based. So that's certainly an interesting area where we're using Hadoop kind of in a critical online manner. And then we kind of start to go down that stack of online to offline. Another large use case for Hadoop at eBay is basically log management. Everything these days is highly instrumented. Where does that data go? At eBay, a lot of that data ends up on Hadoop. And then kind of as a next level from that is, so what do you do with all that log data? We have another solution basically that's built really to tailor around that operational management and kind of metric gathering. So using a lot of that log data, basically we automate the process of either identifying problems or anomalies kind of in our operational ongoings. And then probably the bulk of the infrastructure is in the analytics space, multiple clusters there, and then they're serving kind of the gambit of your typical analytical use cases, whether it's data preparation or data consumption, and using pretty much any technology that they want to that they can. As I mentioned to begin with, one of the pieces of what we're saying is how do you tailor Spark is kind of the optimal infrastructure. So one piece I wanted to share is, well, I mean, what was kind of the starting point, or where do we improve from? And so if we look at Hadoop hardware at eBay, almost all the clusters are heterogeneous. They would have different hardware over the years. So on the core side, 12 to 18 cores is typical, 70 to 128 gigs of RAM, storage in the neighborhood of 24 to 70 terabytes. And basically when we provision hardware, often the case is, say every 6 months, we basically start the process to acquire the cabinets, to get them in the data center, and then once they're in place, in a more gradual fashion, we'll start introducing that capacity to the clusters. So that certainly works, but what I think the call out here is that certainly on the hardware side, those are fine nodes, but I think what we typically see in the Spark sense is that there's a different flavor of hardware really that can really support that better. And then that 6-month kind of cycle of adding hardware certainly works, but there's additional optimizations that could be there too. So Spark at eBay, I mean, I think early on we saw it as a great channel for disruption, a great way to put more capability in our Hadoop developers' hands. So today, basically Spark 1.4 to 1.6. If you're using Spark at eBay and you're doing it at scale, you're doing it through Yarn on basically those general purpose analytic clusters. 20% of those clusters today, so this is certainly growing. It has grown and it's continuing to grow more, but almost 20% of our cluster utilization comes from Spark today. So we've really seen, and Spark is still fairly new, at eBay. We're talking, when we put that blog post, that might have been 2 years ago, and that was the very beginnings, basically. So in 2 years, or less than 2 years, really, we've seen Spark take, a 20% foothold in our clusters. And how people are using Spark and Hadoop at eBay is basically, I mean, I think these are the typical things you'd see at e-commerce. Purchase suggestions, so if you go to eBay and you click an item, these are the things that we think you would also be interested in buying. The marketing optimization, all those great emails you would get from eBay giving you great ideas to spend your time and your money. And then there's really a whole customer angle where we're trying to, for the multi-device user, try to understand, you know, who the customer really is in their journey using eBay, you know, across the spectrum of devices and environments and things like that. And I had the Kylin Q building here, but I was talking with those guys a couple days ago, and that one is actually no longer accurate. But I think the general sense is Spark is very integrated into how we basically traverse our offline data, and that cycles back into the user experience on the online side. Structured data is another big one, basically, and that's a big initiative at eBay. Like I said, traditionally we're search-based, and where other companies are browse-based, and in the browse-based you really need a catalog, right? And eBay has always kind of been lagging in that area, but a huge area basically where and where Spark comes in is a lot of times how, you know, a user creates a listing, right, and to sell something, maybe that's something that's part of our catalog already. In the event that it's not, how do we know what category that item is? And so Spark is certainly helping that as well, and that's a huge effort at eBay right now. Some of the challenges the Spark has, though, as we talked about, it's about 20% of the cluster, and while that's good, that's kind of also bad. And I think at eBay we're not bad. We might be even good at really managing kind of the capacity and efficiency, but that experience is really based on MapReduce jobs. And so with as Yarn came out and we see these other technologies that come in that aren't MapReduce, that's really kind of posing some challenges in terms of how those jobs integrate into the methodologies and kind of processes that we built up over time. So specifically in that space, where some of the Spark challenges we see are the ability basically for the user to size the job so easily. I think there's a tendency for users to oversize the jobs. So that certainly drives an additional consumption footprint. The other piece is the behavior or the duration of MapReduce jobs. There's a certain distribution, and it's fairly reliable in that sense. I think once we get into certainly Spark, that distribution of durations is not the same, and it becomes a little harder to predict and really manage the system accordingly. Today there is more vendor support from Spark than say a year ago, and that one's not so critical, but sometimes it's nice to have that. I think what's more important is our expertise for Spark is spread out across the organization, and so that's certainly been a challenge. A lot of people are interested in using it, but I think there's a certain skill level aspect to it, and kind of at best practices. And so sometimes we haven't been the best at really sharing that kind of information to make everyone the best Spark user they can be. One thing we found that's very simple, but it's actually been very effective for us, is really just a mailing list, an internal mailing list. And that's probably made as big a difference as anything in that way. But we've done internal training, brought in vendors for training, all that good stuff as well. On the deployment side, we basically have a custom Hadoop version. Really the custom pieces around the security side. And while that's okay, what that means is it's hard for someone to basically download a package off the internet and just put it on the cluster. Those kind of things typically don't work out of the box. And so a lot of that, I would just generalize, is kind of the library conflicts. And so that's certainly been an impediment basically for people using it. It also leads to kind of distribution sprawl where at least early on, if you wanted to use Spark, basically you had to build it yourself. And as a result, if we had 10 Spark users, they were all using kind of their own build of Spark that they were managing themselves. And then the other piece is really the configuration pieces, is in the sense of now once you've got your Spark built, how do you actually get it to work on the cluster? And then that's similar to the integration component too of now maybe I've at least got it running, but how do I integrate it with some of my additional Hadoop kind of data infrastructure pieces. So, with that said, I think we're ready for Peter to come on, but I'll just kind of re-summarize some of that real quick. Sorry, Peter. I think eBay is a great business, and you can see where mobile and international is going. We can see hardware-wise, it's okay it's good for Hadoop. It's not great for Spark, and then you can certainly see we're leveraging Spark heavily, but then there's certainly some challenges we've had with that. And with that said, trying to frame up the problem in the environment, I'd like to introduce my colleague Peter, and he's going to talk about basically what Spades looks like and how we solve those problems.
Good afternoon, everybody. My name is Peter Grevsky. I'm architect in analytics data infrastructure, works with John, and we are building Spades. So the goal for the Spades and to have a dedicated cluster for Spark is to streamline developer and analyst experience for interactive or near interactive use cases. We have great experience. You saw before. We have great data, great experience with Hadoop long term. And we want to go to the next step. We can do batch, we can do MapReduce. Now we want to do interactive. So let's see how we can tailor our infrastructure and developer experience for this. So as I mentioned, what we can run jobs. Big infrastructure, huge, really huge data set to analyze. We can definitely test those jobs on developers' workstations, on test clusters. And in most cases, it will be manual or semi-manual. Semi-manual meaning that developer groups automated on group level, on team level, but not on organization level. It works for them. It doesn't work for everybody. And obviously, we can run Spark jobs on our clusters. As John mentioned, 20% of the cluster current clusters, sharing clusters between MapReduce and Spark. So what we want to get. From our new project, our new infrastructure, we want to have flexibility. And by flexibility, I mean infrastructure flexibility. We want to use same computes, same hosts, which currently used for the web application, for other batch processing, event processing. We want to use them for Spades, for Spark. Also, on usability side, we really want to have uniform experience for developers. If developers used to, well, we have great developers, and they can do web applications. Majority of them, and actually really majority of them, do understand asynchronous processing and know how to process the data. However, when they come into the big data processing, experience is different. So we want to have improved usability. And with that, it goes simplicity. If developer can do their job on web application, on batch jobs, he should start from the day one doing their good job on the data processing. Speed. We really want to have interactive use cases covered with Spark, with Spades. And on top of this, we want to have transparency. Transparency means that if I have a piece of code which has to get into production, I need to know where it is on each and every moment. If it's in testing, it should be in testing, and I should see it. If it's in smoke testing on certification process, I should see it. If it's running, I should see it. If I have changed versus non-changed applications, I should see it. So transparency should be there on all different levels. On managers want to see and when the new business initiative will go to production. Developers want to see what's going on with their piece of code and when they can actually mark the task complete. So how we are going to do this and how we are doing it actually. We are running it on Yarn. Many reasons for this. First and foremost is Yarn provides us with authentication from the box. We are using Kerberos, obviously, and we Kerberize in all our clusters. So if you don't have access to, if you don't have GitHub, if you don't have Kerberos ticket and you're not authenticated, so you will not get to the data. For Spark users, this should be transparent. There shouldn't be any other way of authentication other than Kerberos, other than company-wide authentication, and we are doing it with Yarn. Yarn helps us with multi-tenancy. At some point, we thought about self-service clusters versus not self-service cluster, and for the real production use cases for petabytes, to process petabytes data, you really need to have lots of resources. You cannot make 10 clusters with 100 petabytes data. It's just too expensive. So Yarn with queues help us with this problem. We are heavily using queues, which pretty much global across multiple clusters, and that's how we are scheduling our resources in Hadoop cluster, which process MapReduce, and in Spark, where we run in memory processing and kind of faster MapReduce. We also want to have reliability. Yarn is a long-term developed process and project, and HA on name nodes, HA on resource management, resource managers really helps us with it. It's a really stable system, and we know how to make it stable. So experience, that's kind of our another thing. We know how to do Yarn. We're doing it for multiple years. To support new Yarn cluster, whether it will be Spark or no Spark, it really will be transparent for support team. And performance, we did compare simple deployment versus Moses versus Yarn. There is very little difference from use cases we are planning to use, so it's good for us. So how does it fit in our infrastructure? We run in Spades, we run Spark on OpenStack, on internal OpenStack cloud. Reason is very simple. We want to grab some resources from different networks and from different aggregates, host aggregates, and combine them into the Spark. And these resources can come from the test, hardware resource aggregate, or from others. So we really want to share. We want to share our resources, and if, for instance, we have high traffic on site, we want to stop some low priority jobs, or if computes are not needed on the front end, we want to grab them and put it in the cluster, help us with near-time, near interactive processing. We also want to have disaggregated storage. Same reasons as for compute. Scale for the storage is different than scale for the memory. We grow in much bigger on storage, and we want to use all of this in Spark cluster. Not part, not some copy, but all of this. Another important part for us, especially as infrastructure team, we want to see our network flat. Physically, networks is obviously a bunch of switches, router, and all of this combined in nice hierarchical structure, and it's complex. Software-defined networking on C3 and on OpenStack, it's actually help us to think about our networks, about our host deployment as a flat networks. We have one subnet from which we are deploying compute hosts, and that's it. There is no switches, there is no routers. For us, a network is just IP and virtual machine service. And yes, we want to have simpler provisioning. All of the above just give us tools for free. You want host provisioning, go to OpenStack, invoke Nova command, boot new host. You want storage, you can do it multiple ways. You want flat network, it's transparent. It's not even visible for end developers. So provisioning for us, it's really easy. Now, from developer point of view. From developer point of view, we want to see that our software development lifecycle is the same as software development lifecycle in other type of applications. I want that every developer who coming into eBay can do data processing at the same rate, at the same scale, and at the same speed as any web application or event processing application or anything. It should be the same. So the same means that same tools, same processes, same procedures and expectations should be presented from the day one. And for eBay or any big development company, it means that developer need to register application. I mean, everybody wants to sleep good at night and rely on operations to bring up application if it's down. So they need to register application, describe how to bring it up. We want to use same development tools, starting from IDE, which is already used now, to the whole development pipeline with CI/CD. And that includes ability to test as much and with the same tools as developers using for the rest of the type of application. We may need to help developers, of course, with creating single node clusters or few nodes cluster on the fly. That's okay. From the whole infrastructure which I mentioned before, it will be, and it is actually already really easy to do. We have shared computes, we have kind of disaggregated storage, and we have flat network. It's just a matter of cutting it into the right proportions for the right use case. Now, we want to see developers doing single-click deployment. What it means is that as soon as developers give us their code repository, their type of application, and some instruction how to bring up this application if it's down, it shouldn't be concern of developers how to deploy application in production. What we are doing is that we will run through the regular CI pipeline, do developers testing with unit tests. We'll do static code analysis and package application. And after everything is done correctly and everything went through successfully, we will just package application and put it into repository. I mean, there is no need for developers to understand what's going on behind the thing and be involved in the process. That's not the case which we used to in eBay. Developers was involved in packaging and stuff. But we are moving from the older model to the new. And after this is packaged, application packaged, we want to see if application is good. We want to run smoke test and do certification process. That's a certification part which we currently implementing. The way how we are doing it, we are running it on the pre-production cluster with the same integration points and same data set which regular production cluster has, probably on smaller data sets, but we want to see if we deploy new version of application, it's going to be fine We are not screwing anybody while deploying. And of course, runtime, developers shouldn't be involved in the runtime. As soon as application deployed, then it's up to analysts or whoever is responsible for the business results to schedule and get results. That's not the job for developers. To support all of this, we definitely need to have quite a few repositories. We need to have code repositories. Everybody has it now, and we have it, obviously, more than one. And we need to have library repository, application repositories. For library repositories, we have more or less standardized on the Maven type of repositories, but for application repositories, this really may change for us because packaging is kind of very sensitive thing which we are still working on. We need to have, obviously, CI, regular pipeline with CI/CD. We already have it for web applications. We're building it up for big data type of application. And for the to track versions, obviously, you want to see which versions in production, which version was in production, and which version is going to go into production. So we need to have metadata to manage all of this. And to have our cluster more scalable and scalable on demand based on the shared resources on disaggregated storage, we need to have additional, we already have part of it, provisioning system. We need to be able to scale cluster when we have resources, when business needs is such. And we want to reduce the cluster, again, based on business need and current loads. Also, to separate developers from the runtime, we are going to have runtime farm, which is just the way how developers will be able to see if their job running or not, and where job actually will be running. So Spark Job Server is one good example of such hosts, or simple CLI with Spark Submit actually works also very well. And to manage all of this, we are building Orchestrator to push bits from the development through the testing to the packaging to the certification, finally to runtime. We really need somebody who will oversee and manage this metadata, pool repositories, and if needed, extend cluster. So based on everything what I just described, I believe we will have a system which will allow to take developers' work and make it available to the developers and to business users rather than developers, but sometimes it's the same. And analysts in the manual-free manner. We really going to have automated process end-to-end for big data, and this for big data processing, and this will help us to finally achieve our goal for interactive analytics. Thank you. Any questions?
Peter, what part is done and what part is still in
Well,
progress?
we more or less done with infrastructure part of the cluster. So we have provisioning, we have scaling done. Repositories obviously are there. So enhancement of for runtime, that's our next goal. So how we can make runtime farm available, and how we can allow actually to run jobs without developers' involvement. That's actually a big thing for us. That's big mental shift for eBay. Yes. Okay, so the question was about hardware which we had and versus what we are going to have. Our current clusters are shared cluster between MapReduce and Spark, and these are bare metal. So we did experimentation on virtual machines, and we are going to have we are going to have cluster on, and we actually already have cluster on OpenStack virtual machines, KVM-based, 120 gigabytes per node. So comparison on performance, it's actually not that far. Since we own in the cloud as well, it's our private cloud. We have good opportunity to optimize hypervisors and virtual machines. We really have difference in performance in terms of couple % difference between bare metal versus VM. So it works for us. Virtual machines, I mean. Did it answer? Okay.
Storage might be a different piece of that.
Well, storage, yes. We obviously, as I mentioned, we are moving to the disaggregated storage, but again, with cloud, localization is not really a big deal. We cannot really predict which rack virtual machine will go to, so line rate networking and virtual routing and forwarding is actually helping on networking part to optimize and make network fast enough to cover all missing parts for data locality.
Let's say you have separate machines with data nodes or virtual machines and machine with compute. So do you have some statistic on how data locality actually, so could you compare with clusters that use like more monolithic structure when you have Spark workers work on the same nodes as the data nodes, so they have access to local data and short circuit.
So the question was about comparison between jobs running on the data local to the compute versus data disaggregated from compute. We do have difference in the loading and offloading time of the job. The difference is just because local ping, for instance, for VMs, it's 001 or 009 milliseconds, and ping to the bare metal from the cloud, it's about 7 milliseconds. So there is noticeable difference on their loading and offloading. But when job is run, we really didn't see difference more than 2%. Well, we are relying that majority of the data will fit into the memory.
You told that you use heavily batches, but your business is more about responding real time. So how do you deal with real time?
Interactive, not real time. We do want basically we are not there yet. We cannot really satisfy jobs which has a SLA few minutes. Right now, amount of data we have and the amount of data we have, it's literally up to 2 trillion records, which have to be mapped into another few thousand records and get joined out of this. It's really too big for us and for the cluster we have. We are growing the cluster, so we basically trying to do brute force, just add more capacity and see if it works. And we also try to optimize loads. So if load is really expecting lots of resources and we simply don't have it, then we just should either reduce use case. I mean, we can do what we can do. or we just have to have SLA. If your job is not running, if your job running is longer than 2 minutes, it will be killed. That's our current approach. Any other questions? Okay.
You mentioned about you extend clusters. So how it's usually done? You are running a separate VR cluster with a measure or whatever, or you just like, to run something, you just add more nodes to this VR cluster and remove them once they are not.
The question, how we are really managing resources right now, the all clusters in Bay right now is just growing. So we do have separate Yarn cluster, and we are planning to add more capacity to it. And but then again, same rules as you said. If we don't use some compute, we will just delete it. Since we have disaggregated storage, we don't have to actually migrate data from those clusters, so from those nodes. So it makes us do it faster and easier than. Any other questions? Okay, thank you.